Hello and welcome back to Above and Beyond CDL Driving's Academy's permit prep course. Today we're going to start on section 5, which is the air brake section. So I have to apologize. You'll have to bear with me here. The final product will have explosions, fireworks, lots of drama, lots of action. But unfortunately, this is the version you're going to have to deal with until I get that version completed. So bear with me, we'll get through this together. My name is Brian Hudson. My contact information is up above. As I've said many times, don't hesitate to reach out to me, especially if you failed the permit test as well, the general knowledge, the air brakes, or the combination. If you failed it 3 times, please reach out to me before you take it for a 4th time, because after the 5th time, there's a good chance they will make you wait a total of 12 months before you can retake the test again. So make sure you study. There is no excuse for not studying. This is not in place of studying. This is a supplement to you studying. And also all those practice tests online. They're all basically going to be the same version of the same questions that may not even be on the test. So make sure you study. To study, you can download your free CDL manual right there. Study sections 1, 2, 3, 5, and 6 of this free CDL manual. If you do not do well with studying off computer modules, then come into our school, rent one of our CDL manuals for $5. We will actually give you the $5 back when you bring back the CDL manual in the same shape as when you borrowed it. We just cannot keep giving them away for free because it's like 400 pages to print off and the cost of the 3-ring binder. Okay, moving forward to the dull part of the presentation, air brakes. Air brakes obviously use compressed air to make them function. There are 3 different functions of an air brake system. First one's going to be the service brake. Every time you step down on a brake, that is one of the functions of the air brake system. But there's also 2 other functions that use the same technique, the parking brake and the emergency brake. On those, we take away the air to engage the brakes. So moving on to the parts of our air brake system. Sorry, I just got a message and got distracted there for a second. Try moving forward here. Parts of the air brake system right here is a very simple drawing of an air brake system. So the compressor is run off of the engine either via a belt or a gear. The compressor will start to build up air pressure into the air tanks. And what the governor or regulator does is it regulates the amount of air that air tank will hold so that we don't end up building up so much air pressure that we end up blowing a line or blowing that air tank up into pieces. We also have a safety valve on that air tank too, so we cannot overcharge that system in case the governor or regulator does not work properly. From there, it sends air up to the brake pedal. When we depress the brake pedal will then send air out to the brake chambers, which will then push the push rod out, rotating the slack adjuster and then rotating those S cams, which are lobed, which will then push the brake pads against the brake drum. So we'll talk a little bit more in depth here. The air compressor is what actually creates the air. It will start to compress that air into pounds per square inch. On that air compressor is a governor, which is then going to regulate how much air goes into our system. So it will cut in and allow the air compressor to start charging at 100 psi, and then it should somewhere between 125 and 140, the compressor will cut out so that we are not continuing to overcharge our system. Most air brake equipped vehicles are going to have 2 air tanks, a primary and a secondary, which we'll get into in a little bit more farther down the road here. On the bottom of those air tanks are going to be drains, because as an air compressor starts to compress that air, it starts to create moisture. That moisture will always fall to the lowest part of the system, which is the air tanks. And at the bottom of the air tanks, we'll have drains so we can drain that water out. Our tanks should be drained daily. There's 2 different kinds of tank drains. There's the manual, which is us having to drain them manually, or the automatic, which once it senses a certain level of humidity will drain it down. The reason that we have to drain the moisture out of our system is to avoid rust. And what happens when water freezes or water gets below 32 degrees, it will freeze, and then it will freeze up some of our air lines, causing our service brakes not to work properly, or will not allow our brakes to release at all. Some trucks are equipped with what's called an alcohol evaporator, and that alcohol will mix with the moisture in the system and lower the freezing point on it. Doesn't mean that we don't have to drain it out of our system still. It just means that it is at a lower freezing point. So we still need to make sure that we're draining our tanks daily. The safety valve, like I was talking about on our air tank, is a redundant system, so we don't overpressurize our system. At 150 psi, the safety valve will pop off, and it will lower the air pressure in our system, so we're not blowing our air lines or any of our air brake components. And then we finally have that service brake pedal, which is pictured on the screen right there. You press down on it. It's a variable valve, basically, is what it does. The more pressure you put down on it, the more it's going to allow air in to activate the brakes. We do have parking brakes on our vehicles because we don't have a park gear like we do in a car. We have a parking brake instead. So the yellow square one is going to release the tractor brakes or apply the tractor brakes, and the red is going to provide air to the trailer to release the brakes or to apply the brakes with the absence of air. So we push in to release it, and we pull it out to engage the brakes. We also use those for parking. Our spring brakes are activated by the absence of air. So the presence of air in our spring brakes will release our brakes. If we take that air away, it will activate our emergency or our parking brakes on our trucks. We also have what's called a hand valve. It is spring loaded, and it will gradually activate the spring brakes on the trailer. Not every truck has those. They're actually an optional equipment. Some Freightliners don't have them. And then we also have a dual parking control valve, which is going to be mostly on buses or some specialized vehicles as well. What that does is if we have a catastrophic failure of our air brake system where we lose all of the air in our air brakes, there's a separate tank that will temporarily provide enough air to release the brakes to get our truck or bus moved off of the roadway and parked in a safe location. It is not meant for driving. It is just meant to move it enough to get it out of a bad situation so we can park our truck in a safer location. Here's a picture of a brake chamber on the slide right there. So you can see the one on the right with the heavy duty spring. That is going to be our parking brake or spring brake chamber. So what that does is when you provide air in, it will compress that spring, which pushes the push rod out, which releases the brakes. On the other side, the one that has the black line that says service brake clamp, the air will go in there, and then it will pull that push rod back to the right and activate our brakes again. So one side, the absence of air will activate the brakes. The other side, the presence of air will activate the brakes. The push rod runs through that entire brake chamber. It is attached to the slack adjuster, the automatic slack adjuster by a clevis pin. And then the automatic slack adjuster, when we push on the brakes, will push that push rod out, and it will rotate that slack adjuster, which has a shaft that goes into the S-cam, which then rotates that S-cam and pushes the brake pads against the brake drum. There are 4 different types of foundation brakes found on each axle of the truck. There's the S-cam, which is the most common one, where it has the S-cam, which the S is lobed, put onto a shaft. As that shaft rotates, it'll start putting pressure onto those brake pads and put them against the brake drum. Then there is the wedge, which pretty much is the same thing. Instead of an S-cam, it's going to be a wedge that goes between the brake pads. As it pushes down, it starts to separate those brake pads and pushes them against the drum. The rotor or disc brakes have a caliper and a rotor the caliper will squeeze the brake pads against the rotor. And then you have an air over hydraulic system, which will use a mixture of both air and hydraulic fluid to activate your brakes. So here's a picture of an S-cam. Oops, I went too fast there. I passed through that slide. I don't think I can go backwards. And then here is a picture of a disc brake system. It has the caliper on the left, the yellow piece right there, and then the rotor is the shiny metal part. So as that caliper squeezes on those brake pads, it starts to squeeze against that rotor and slow down the rotating of that rotor. All air brake equipped vehicles are required to have what's called a supply pressure gauge. It will indicate how much pressure is in the system in pounds per square inch or PSI. Normal operating range should be somewhere around 120 to 125, but it will drop all the way down to 100 PSI at times as well. Some trucks are equipped with an application pressure gauge. What that does is if you're not pressing on the brakes, your application is at 0 PSI, and then it will measure how many PSIs it takes to actually activate the brakes. If you're driving the same exact vehicle all the time, if you start noticing that your vehicle is taking more and more air pressure to activate the brakes, then there is an issue with your brakes are out of adjustment. All air brake equipped vehicles are also required to have some sort of a low air pressure warning. It should activate somewhere right around 55 to 60 PSI. And a lot of times, unless the truck is running, when you're doing your brake checks, it will not activate an audible alarm. It will only be a visual alarm. But if your truck is running while you're going down the road and you hear this buzzing, and look down and it says that your brake air pressure is low, that means you had better pull over soon because you have a catastrophic air leak somewhere. We also have stoplight switches on your personal vehicles. Those stoplight switches activate when a plunger is pushed in, and then it will send an electronic signal to your brake lights to light up. On an air brake equipped vehicle, that stoplight switch is activated by air. So when you step on the brakes and it starts sending air to the brake system, it will automatically flip the plunger on in your air line, and then it will activate your stoplight. One thing you're going to notice in this one and in this module and then in the next module talking about combination vehicles is the year 1975. You're going to notice a lot of technology started to come into the truck driving world in 1975. Prior to 1975, what they used to put on trucks when it was a switch, it was a front brake limiting valve. So if you were not hauling a trailer, it would limit the amount of air that would go to your steer tires, your front steer tires, because the thought is that if you put too much brake pressure on your front tire, you could easily lose control, or that truck could actually tip over because all your braking power is in those front wheels. These were all in pre-1975 vehicles. What they found out after 1975 is they don't actually need those. Front wheel braking is good under all conditions. In fact, most vehicles use front brakes are going to be the ones that get the most brake pressure on them. So they no longer put those front brake limiting valves in there. Our air brake equipped systems are actually dual air brakes. So that means there are two independent brake systems using the same exact control. So when we step down on our brakes, we have the primary system, which will activate certain axles, so axle 1, 3, and 5, say. And then you have the secondary system, which will activate brakes on axle 2 and axle 4. The thought is if we have a redundant system, if we experience a failure in the primary system, at least in the secondary system, we'll still have braking abilities. There's usually going to be two different gauges. Could possibly be one gauge with two different needles inside with a green and a red needle. Doesn't matter, your low air warning light should activate when you're between 55 and 60, no matter which gauge you're looking at. If you do have low pressure on one system, it could actually affect the brakes that are served on that axle. So inspecting the brake system is a little bit different than hydraulic brakes. So we got to check the air lines running into our brake chamber to make sure there's no abrasions, bulges, and cuts. We have to check the brake chamber to make sure it's securely mounted and it's not cracked, damaged, or loose. And then also you'll notice on that brake chamber too, there's a C-clamp on there. If that C-clamp breaks, the whole brake chamber will split apart rather than push that push rod out. So that's why you got to make sure that C-clamp is fully in place. After we are coupled and uncoupled, we want to make sure that we do our tug tests. So we'll release the trailer brakes and apply the tractor brakes, attempt to pull forward. Tractor brakes should hold. Then we want to release the tractor brakes and apply the trailer brakes. And what we're doing there is we're testing to make sure that the trailer brakes are working properly and that our whole system is coupled together properly as well. Then we'll release both of our brakes and roll forward to approximately 5 miles per hour while we're loosely holding the steering wheel and firmly step down on the service brake. If we feel the truck pulling from right to left, that means that one of our brakes is probably stuck on the side that it's pulling to, or the other side may not have enough brake adjustment on it. And then we're also giving the opportunity for those automatic slack adjusters by giving it that full brake pressure, full brake stroke to adjust those slack adjusters to compensate for the wear of our brake pads as well. Next, we're going to do what we call a lab test. It basically means a leaks, alarms, and buttons test. We're going to first of all charge our system until the regulator releases somewhere between 120 and 140 psi. Then we're going to shut the truck off, turn the key back to the on position, release both the tractor and the trailer brakes and the service brake, and then once those gauges stabilize, we're going to hold that brake down for 60 seconds. That's the L part of the lab test, the leak part of the lab test. We want to make sure if we're in a straight truck that we do not lose more than 3 psi. And if we're in a combination vehicle, a tractor trailer, the FMCSA is very generous with us and give us 1 extra psi to lose in 60 seconds. Which, if you look at the thickness of that gauge right there, if you look at the gauge, there is no mark for 3 to 4 psi. So basically, you have to assume if that gauge moves at all, that you have an air leak anywhere. Then we're going to test the A part of our lab test, the alarms, by fanning down our brakes until our lower system activates. So we're going to pump the brakes until the lower system activates somewhere right around 55 or 60 psi. Then we'll test the B part of our lab, the brakes or buttons, and we'll pump our brakes until the red and yellow button pop out, and that should happen somewhere between 20 and 45 psi. If we fail that test, that vehicle is not safe for the roadway. Using air brakes is going to be the same exact thing as in any other vehicle with normal stops. First thing we're going to do is try to maximize that engine braking effect by downshifting and try to control our speed. And then once our RPMs are down to idle, and then we can start touching the brakes and using them to come to a nice, easy, slow stop. We just want to make sure that's a smooth stop. Once we're stopped, never put the truck in neutral. Always leave it in a gear with the clutch pushed in. We always want to make sure that we're using that controlled braking where we're braking right to the point of almost locking up, but not quite locking the brakes up. This is the best way to use with ABS, so if you accidentally press too hard, the ABS system will compensate for that and keep you from skidding. And then we want to make sure that we hold those brakes until we are stopped. Stab braking would be used prior to ABS equipped vehicles, where you would pump the brakes until your wheels start to lock up, and then you'd let off the brakes, and you'd pump them again, and you just keep doing that until you're stopped. But remember, the whole goal of coming to a quick stop in a vehicle is to keep that vehicle in a straight line and under control. So the faster you drive, the greater the striking power is. We talked about this a little bit in previous chapters. If we double our speed, we increase the impact power by 4 times. Remember that empty vehicles are going to take longer to stop based on having less traction. Heavier vehicles have to work harder and absorb more heat, but that's what they're built to do. The trucks are built to be heavier. The brakes, springs, tires, and shock absorbers are designed for those heavier vehicles. If you do experience brake fade or failure, it's usually caused by overheating. We're either riding the brakes or we're not using enough engine braking by overusing our brakes. High heat is going to cause a chemical change in those brake pads. That's the term glazing over. And instead of becoming creating friction, they're just going to create like a glaze over the top of the brake pads. Or another problem that we could have is we're putting so much heat onto those brake pads, metal expands when it gets hot, and then pretty soon those brake drums have expanded. It doesn't take much, maybe a 1/16 of an inch, but then they're no longer touching those brake pads, and that's how we end up with brake fade or failure. If we have brakes that are out of adjustment, that means the other brakes have to pick up the slack for those brakes that are out of adjustment. So eventually you got one out of adjustment that's not grabbing, another brake will start to overheat, that one will then start to get brake fade, and then the other wheels will similarly follow the same exact process. Remember that brakes are a supplement to engine braking. So if we're going to go down a hill, we have to determine the safe speed before we crest over that hill. Then we're going to downshift into lower gear so that our RPMs are up higher, which will then allow that engine braking to take effect, and it will retard the acceleration of our truck until we get to the safe speed, and then we'll use our brakes to lower ourselves down to 5 miles below the safe speed, and then we'll let off the engine again and let off the brakes again and let the engine retard the acceleration again, and just keep that whole process over and over and over until we're at the bottom of the hill or the mountain. All emergency air brake equipped vehicles are equipped with low air pressure warning that should activate somewhere between 55 and 60. If you're driving on the highway and that comes on, you better pull the truck over immediately, because what's going to happen is you're going to eventually lose all of your air. And once you get to 20 to 45 psi, all of your brakes will lock up and you will lose control of your vehicle. So it's best to pull over and be stopped before that happens, because if it locks up while you're going down the road at highway speeds, you will lose control of your vehicle. So we have to use our parking brakes. Should always use those when parking. The only time that you would not use them when parking is when your brakes are overheated or when they're wet. In that situation, we will chalk the wheels, leave the brakes released, and chalk our wheels until they've cooled down or the water has drained off of our brake pads. Because if you lock brakes with wet, cold brake pads and it's below freezing, those brake pads will eventually freeze to that drum, and then you got to crawl underneath there with a hammer and pound on that drum to get that drum to release those brakes. So those are the only two times that you do not set the parking brakes. But before you leave that vehicle, you have to make sure that you do set those parking brakes. And don't forget, we have to drain the air tanks at the end of each day to get that liquid out of our air brake equipped vehicles. The only thing that should be in an air brake equipped vehicle is air. There should be no other fluids, nothing else in there, just air.